All right, so the notes for 1.2, here we go. 1.2, operations with real numbers. Write the rules for adding and subtracting integers in your notebook. There's not really rules, but there is something we have to follow. Karan, when we're doing order of operations, what do we have to follow?
PEMDAS.
PEMDAS, very good. And I do like PEMDAS, and I also hate PEMDAS. So let's write PEMDAS at the top of our page. Now, PEMDAS, later on, they're gonna change it to GEMDAS. They just changed the P to a G because somebody wanted to be funny and reinvent the wheel. So they changed it from parentheses to grouping. Nobody really cares about that. But the reason why PEMDAS is good is it's a nice, easy way for you to remember. The reason why it's bad is kids often mistaking that multiplication always comes before division, and it's not. They kind of are in a group together. So I like to think of it as multiplication or division, addition or subtraction. So Abigail, A, 12 plus negative 10. Do you know what that is, Abigail?
2.
2. That's it. Nice and simple. Damien, negative 3 plus negative 17. What would that be?
Negative 20.
Negative 20. And then I got C. So these, I can see how you're inclined to use a calculator and just type it in. I noticed that they're both negative, so I'm really like adding here. So this is going to be 0.18. 5 plus 6 is 1. Carry my 1. 4 plus 3 plus 1 is 8. So it's going to be negative 8118. And I would say you can check it, but you don't have to because I just did this last period. Any questions on adding integers? Now with subtracting integers, we have to be careful of problems like C, and I'll go over why when we get to C. All right, so let's go over A. Mark, what do you got for A? Negative 5 minus 9.
Negative 14.
Perfect, negative 14, okay? Now, a problem like B, I got it. If we're doing negative 13.2 minus 9.6, again, I'm kind of thinking like I'm going to be adding these two. If I borrow $13.20 and I borrow $9.60, I have borrowed a total of, let's see, $22.80. And borrowing's not good, so it's going to be negative $22.80. Now, why did I say you have to be careful of problems like C? Because, Ben, what's a little weird about C? What do you notice in the middle of that problem?
Me?
Yeah, you're Ben.
Sorry, what was the question?
Ben, what do you notice in the middle of that problem? There's 2 what? In C, under example 2.
I'm sorry, it's really laggy for me.
It's okay. Do you know the answer to C?
Yeah, it's 15.
15, perfect. So the reason why C can be a little tricky is because we have these 2 negatives here, so we can't forget that 2 negatives make a positive. All right, and that's my first thing that I do there. All right, let's go to example 3. And example 3 is a lot like what we just did, just a little bit longer. So in example 3, okay, we have 4 minus negative 11 plus 9. So I see these 2 negatives here, so I'm going to change it to 2 positives. 4 plus 11 plus 9, well, that's going to be 24. Anybody think they have B? Anybody want to participate?
Is B 13?
It is 13. So the 2 negatives right here, all right, make a positive, so I have plus and plus, okay? My board wants to stay aligned. So I have the Ooh, that's bad. So I have those two positives there. 6 plus 24 is 30, minus 17 is 13. Nicely done. All right. What do I have to remember about with fractions? So, Joe, what do you know about fractions? When I'm dealing with fractions, what do I have to pay attention to?
The common denominator.
That's perfect. So, let me scroll down a little too far. Let's write when adding or subtracting fractions, we need common denominators. All right, so I can do problems like A really quickly and really easily, but problems like B and C, I need to do a little bit of work for. So let's pick on Sarah. Sarah, do you know what A is? If I do 5, 6, 7, 6, what is that?
Would be negative 1, 6.
What was that? One more time.
Would be negative 1, 6.
I think you're doing two things in one step. So 5 plus negative 7 is negative what? Negative?
I didn't hear what you said, sorry.
It's okay. 5 plus negative 7 is negative what? Oh boy. We got some status. So here, 5 plus negative 7 is negative 2. And this is what I think you were doing a lot in one step. So we would change the numerator. We do 5 plus negative 7 get negative 2. The denominator stays the same. And Sarah, I think you were trying to reduce all at once. So you're trying to do the whole problem and reduce. Because we do have to reduce this. And once I reduce negative 2, 6, I get negative 1/3. And Sarah, that's what I think you were doing there. Okay? So when we're dealing with fractions, what we want to do is we want to complete the problem and then reduce it. All right? So if we can reduce our fraction, that's what we need to do. Now, Emily, how are you today?
Great.
Fantastic. Emily, are the denominators the same in B?
No.
No. So I have to find a common denominator. Do you happen to know what that common denominator is?
No. Is it 24?
It is 24. Say it with confidence, 24. All right. So I'm going to rewrite this problem here. So I rewrote the problem. I gave myself a little space. Now, Emily, how do I make an 8 a 24? What do I have to multiply by?
3.
3. So I'm going to multiply this first fraction by 3 over 3, because 3 times 8 is 24. Emily, how do I make a 4 a 24?
6.
So I'm going to multiply by 6 over 6. And then I'm not going to insult you. You make a 6 a 24 by multiplying it by 4. So now I just made a common denominator. So I'm going to kind of simplify these fractions, all right, each piece at a time. So the first piece would be 15 over 24. The second piece would be 6 over 24. And the third piece would be 20 over 24. And 15 plus 6 is 21 minus 20 is 124. Easy enough? I'll give you a second to copy that down. All right. Let's move on to C. And I'm sure a bunch of you guys are pretty scared about a problem like C, but I wouldn't be scared about C. Here's the reason why. Okay? What's the common denominator between 4 and 8? Let's go with Mr. O'Donnell.
8.
8. So if I kind of think about how do I make a 4 and 8, I'm going to multiply it by 2, right? So if I make 3/4 out of 8s, that's going to be 6/8. Mr. O'Donnell, would you agree that 3/4 and 6/8 are the same?
Yeah.
All right. So 5 and 6/8 plus 7 and 3/8 is 12 and 9/8. But 9/8 is 1 and 1/8. So this would be 13 and 1/8. You guys see how I did that? Are you okay with that? Or is that too much? And you can be like, whoa, Harmon, that's too much. Mr. Emmy, how you doing, buddy?
I'm good.
You're good?
Yeah.
All right, good. All right, let's go to the next page. All right. When we multiply fractions or numbers, things like that, okay, it's way easier than adding or subtracting, okay? So 3 times -9 is what, Owen?
-27.
Perfect. Marcus, do you happen to know what -2 times -6 times 4 is?
Would it be -48?
Close. So negative times a negative is a,
Oh, it's a positive, so it's 48.
yeah, it's just 48, okay? So what I like to do, Marcus, is I like to determine first off if my answer is going to be positive or negative. So like with A, I have a positive number times a negative number, so I know my answer is negative, and then I can just focus on what is 3 times 9. With B, I'm looking at -2 times -6. That's going to be a positive number times another positive number, so I know my answer is going to be positive. Does that help you out at all?
Yeah.
So just determine if it's going to be positive or negative. So like in C, I'm looking at that and I'm saying that's going to be a negative answer. So now that's one less thing I have to worry about. So I have 1/3 times -3/4 times 2. Now there's a couple different ways to do this, okay? First one, let's make it all fractions. And then I can multiply across. 1 times -3 times 2 is -6. 3 times 4 times 1 is 12. That's -1/2. So that's one way. And then there's a way I like better. I think it's smarter. Okay? Now, can I erase this? Fantastic. All right, the smarter way to do this problem, and I'm just going to write it bigger. Okay, again, I make that a fraction, but now I cross cancel. That 3 and that 3 cancel. That 2 and that 4 cancel. So now I have 1 times negative 1 times 1, negative 1. Okay, this was a 1, so 1 times 2 times 1, 2. Now, why would I use something like that? Well, when we're dealing with bigger numbers, my answer is going to be bigger. And then I'm going to have to reduce. And I find it easier to reduce as you go along than it is to deal with it at the end. All right, what do I have to pay attention to when I divide fractions? Caitlin, do you know what you do when you divide fractions? And it's okay to say no.
You have to turn them into improper fractions.
What was that? I can't hear you over my AC.
You have to turn them into improper fractions.
Sometimes I do. That is correct. There's a big word and it starts with an R and rhymes with atypical. At least I think it rhymes with atypical. Anybody know it? Starts with an R.
Reciprocal.
Reciprocal. So we have to multiply by the reciprocal. And at times, it's going to be an improper fraction, especially with a problem like C. We're going to have to make improper fractions. So first off, let's start with the easy one. Negative 27 divided by negative 9. Karan, what is that?
Would be positive 3.
Positive 3. Perfect. Now with a problem like A, I have to flip my second fraction. So I have to multiply by the reciprocal. So this would become 27 over 14. And I can't reduce that. Now, Miss Price, this is what you were talking about. Right? Specifically, you said I had to make these improper fractions. Do you know how to make them improper fractions?
Yeah.
All right, what do I do?
So for the first one, you have to multiply 4 times negative 4 and then plus 1.
Okay, now be careful with that one. All right, because a lot of kids will say 4 times negative 4 is negative 16 plus 1 is negative 15. And if my Spanish is still good, that's a no bueno. It's not good. Okay, I don't know what it is in Chinese or French, but maybe I'll learn that. So what I need to pay attention to here is when I do what Caitlin said, when I do 4 times negative 4 plus 1, well, I want to make sure that my whole fraction's negative. Okay, so I do 4 times 4, that's 16, plus 1 is 17. So this is going to be negative 17 fourths. Divided by, here, we're going to have 8 times 5 is 40, plus 5 is 45 eighths. So now I can do negative 17 fourths times 8 45ths. And this is why I said to cross cancel. Not a 2. Oh no. One. There's my 2. So I would get negative 34 over 45. And that's where I'm going to stop for today. And that's how the cookie crumbles.